we want to prove that cos 30 is equal to the root of 3 upon 2 or 0.8660. And after that, we'll prove also that tan 60 is equal to cos 30 all over sine 30 degree or 1.7321. Since we're dealing with 30 and 60, we can actually use the same triangle to represent the proof that we want to solve right now. Therefore, I am going to begin by constructing a triangle. This time around, an equilateral triangle is what I want to construct. Therefore, let's do it right away. I create an equilateral triangle of this nature. I'll tell you why I am creating an equilateral triangle. In fact, before I finish creating, maybe you get the point straight away. Okay, we are going to use this triangle. Please take note, it is not drawn to scale, okay? But we're just going to use this triangle to represent our equilateral triangle. Oh, this is it. Yes, this should represent our equilateral triangle. Let's call this equilateral triangle ABC. Since it is equilateral, it means that all sides are equal. And in that case, all the angles are also equal. When all sides and all angles are equal in a triangle, it means that the measurement of each angle is 60 degrees. The reason for this is so that when we want to prove tan 60 degree, it will not be a very big barrier for us. Now, for us to find 30, which we'll be working with in place of cos 30 degree, I will have to bisect this triangle in two. I will have to bisect this in two parts. And remember, bisection of a triangle simply has to do with creating it into two equal parts. What this also implies is that the angle at the middle, which is this angle at A, has been divided into two parts, two equal parts for that matter, with each of them measuring 30 degrees, as you can see now. Now, because this whole triangle is an equilateral triangle ABC, it also means that all the sides are equal. So I can choose to give it the dimension x for the sides. So each side of this measures x. Now that I have just bisected angle A, the line BC has also been bisected into two equal parts, with one part measuring half of x and the other side also measuring half of x, because they are equal. Take note of that. All right. Now notice that what we currently have in each of the triangles are angle 60, angle 30, and angle 90 in each of the triangles we have here. So first thing to do is to find the dimension AX, which currently is unknown. So to find that, notice that in a right angle triangle, we have the hypotenuse AB, as you can see here, while on this side we have it as AC. But since I'm working with the right angle triangle ABX, my hypotenuse is X. My adjacent can either be AX or BX, but the part missing is the line AX. So to find that, I am first of all going to apply the Pythagoras theorem, which states that the square of the hypotenuse is equal to the sum of the square of the other two sides of a right angle triangle. Hence, I am going to say right now that bx squared, which is this line here, bx squared add ax squared is equal to ab squared. You already know this, I believe. All right. So since ax is our major focus, we make ax our subject here. So ax squared, that is line ax squared, will be equal to ab squared minus bx squared. This is what we are going to apply to find out the value of ax. Now, ax alone will be equal to the square root of ab squared minus bx squared. This is what we are looking for. So let's find and substitute the values for AB and BX in order for us to find exactly what AX will stand for. So we come down a little more. AX right down here will be equal to the square root of. Now come back to the triangle ABX that we are working with. The dimension of AB is x. So AB squared will be the same thing as x squared. Minus, what is the dimension of BX? BX measures half of x. That is half of x. But remember the squared. So half of x squared everything. We are going to simplify this inside the square root first before taking its square root finally. So this comes down to x squared minus 1 squared is 1, x squared remains x squared, and then 2 squared is 4. So we have 1 upon 4 of x squared. Now we can solve this fractionally in order to simplify what is inside the square root. So our ax will be equal to the square root of 4 times x squared is 4x squared. 4 times x squared is 4x squared minus 1x squared, or just write it as x squared, all over 4. When further simplifies, this ends into, I'm going to bring it to this side. So when we further simplify this, it's going to be ax is equal to the square root of 4x squared minus x squared is 3x squared all over 4. Now we can simplify by finding the square root of what we have currently. Now ax will be the square root of 3x squared. Can only have x outside, while root 3 remains in root 3 because we can't afford to come with decimal this time. So all over, what is the square root of 4? The square root of 4 is 2. So we have ended up finding ax to be dimension x root 3 all over 2. This is what we are going to be working with for us to be able to prove the rules cos 30 and tan 60. So with this already done, the full dimensions of this triangle is complete. They are complete. So let's find it out currently, what cos 30 will be. Now remember SOHCAHTOA, which I told you is the acronym that you can always use to find trigonometric ratios. SOHCAHTOA. So for us to find cos 30, so is out of the line because so stands for sine, which is opposite all over hypotenuse. We are dealing with the car part, which means cos theta or cos x or cos whatever we are dealing with is equal to adjacent of that divided by the hypotenuse. I'll just write that down. The cos of whatever we are dealing with is equal to adjacent divided by hypotenuse. So since cos 30 is our focus this time, it's going to be cos 30. Now look at the triangle we're working with. Since we're working with triangle ABX, our 30 stands as A. So cos 30 will be adjacent. What's the measurement of our adjacent? That is the AX part that we just dealt with right now. So it's going to be AX all over our hypotenuse is AB. We are going to substitute into this expression right now. Now AX has already been found above to be x root 3 all over 2 divide by or all upon AB. What's the measurement for AB? AB measures just x. So if we simplify this further by dividing both the numerator and the denominator by x, cos 30 degree will be equal to cancel out x on the denominator and cancel out s on the numerator, and you are left with root 3 all over 2. This is the answer as required. Take a look here. Cos 30 here is given as root 3 all over 2, which we have just proved to be correct. But is it true that root 3 all over 2 will also give us 0.8660? And when we find it on calculator, will it be the same? Let's check it out. First, I'm going to work with the calculator this time. Let's see what root 3 all over 2 will what. So root 3 divided by 2. What is it? Can you see on screen? That gives us 0.8660. So I'm going to write it down that this is true for what has been said above, 0.8660. But there is another way to confirm if that is true. You can just punch cos 30 on the calculator. This way, cos 30 is equal to the same thing, 0.8660. So at the moment, we have just proved the first part. I hope this is clear enough.